Hey y'all, welcome back. On tonight's homework, we are working with separable differential equations. And really, what that means is that we're going to be given an equation that represents the slope of a certain other equation. And our job is to figure out what that is. So, number one says the slope of the graph of f of x is given by 6x plus 3, and the graph passes through the point 2 comma 5. Part A says write the equation of the line tangent to the graph at x equals 2. So just like we've done in the past many times before, anytime we're asked to find the equation of a line that's tangent to the graph, we are going to set this up by first identifying a point on the graph and also identifying the slope at that point, and finally writing the equation in point slope form, y minus y1 equals m times x minus x1. So the point that we can use is given in the problem. It's 2 comma 5, so we may as well just go ahead and use that one. And then the slope, well, we've got to figure out what the slope is at that point. The slope of the graph is given by 6x plus 3. So if x is 2, 6 times 2 is 12, plus 3 is 15. So our equation, we're good to go to set it up at this point, is y minus 5 equals 15 times x minus 2. We can then use that line to approximate the value of f of 2.1. All we need to do is substitute in 2.1 into x and then solve for y, and we should have our estimation. So y minus 5 equals 15 times 2.1 minus 2. 2.1 minus 2 is going to be 0.1. And this would be a question that I think would be fair game for a non-calculator portion of the test. So I'm going to go ahead and not use a calculator until the last part when we will actually need the calculator. So 1/10 of 15 is 1.5. And then if I add 5 to both sides, I get y equals 6.5. So we can say that f of 2.1 is approximately 6.5 using that linear approximation. Part C says determine the equation for f of x. So this is where we're actually going to find y, and we're going to do that by going through the process that we talked about in the notes. First, we'll try to separate our x's and our y's, then we'll integrate both sides, figure out what the c is, and we'll be able to write our equation. So it says the slope of the graph of f of x is given by 6x plus 3. If that's the slope of the graph, that means that's dy dx. Okay, it's the change in y over change in x. So the equation that we really want to start with here is dy dx equals 6x plus 3. Now, notice that there's no other instance of y here. So really all we need to do is move that dx over and rewrite this equation as dy equals 6x plus 3 dx. And now we're good to go to integrate both sides. So I'll integrate the left side, integrate the right side, but in terms of different variables. The left-hand side will be integrated with respect to y, and the right-hand side will be integrated with respect to x. Now, the integral of dy, you might think of this as like 1 dy. So if you're wondering, what function has a slope that's 1, well, it's just one, if y equals x, if we're in terms of x, since we're in terms of y, it's just going to be y. So we have y plus some constant. Okay, I'll just call that c1, although you can call it cy, or you could just call it any constant, equals, and now we can use the anti-power rule to integrate the right-hand side with respect to x. So I'm going to increase that exponent by 1, making it x squared, and then dividing 6 by 2 to get 3x squared plus 3x, and then it's got its own little c value over here. So if I move the c's and combine them, I'm going to get y equals 3x squared plus 3x plus 3. Now that we have an equation for y, we can go ahead and try to figure out what that c is. And we can do that by substituting in that point that we know has to be on the curve, 2 comma 5, into x and into y. So 5 equals 3 times 2 squared plus 3 times 2 plus c. 5 is then going to equal 3 times 4, which is 12, plus 3 times 2, which is 6. 6 and 12 make 18. And if I subtract 18 from both sides, I'm going to get negative 13 as C. So that's pretty much it. Now I just need to kind of put it all together and rewrite this equation that I've got here, except instead of writing C, I'm going to write minus 13. So my answer should be y equals 3x squared plus 3x minus 13. One quick thing that I want to note here is that since we did not have any other instance of y other than the dy, we really didn't need to separate anything out. We could have just integrated both sides with respect to x and gotten the same answer. So if you would have just found the integral of 6x plus 3, you would have got 3x squared plus 3x plus c anyway. So I kind of did more work than was necessary, but I kind of wanted to set us up to be prepared for the future questions on this homework where you would actually need to find, would need to actually separate out the x's and y's. Now the last part, which says E, but D comes after C, so I guess something got left out there. We got a little typo there. But anyway, find the value of f of 2.1. We used a linear approximation back in part C to actually find that. But at this point, we're actually going to figure out what it is exactly because we know the equation for y now. So y is going to be 3 times 2.1 squared plus 3 times 2.1 minus 13. And it even specifies that we are allowed to use a calculator here. So I'm going to use a calculator out to the side. I'm not going to bother pulling up Desmos because there's nothing really fancy about what I'm typing in here. I'm just going to do it off to the side. I'm doing it as I speak here, and I get 6.53. So since this is 6.53, we know the exact value of f of 2.1 is 6.53, which is pretty close to our linear approximations. Linear approximations are usually pretty good approximations as long as you don't veer too far off from the value that you know. So we knew what f of 2 was. We knew it was 5. So f of 2.1 should have a pretty decent linear approximation. If we tried to use that line to estimate, say, f of 20.6 or something that's way far away from 2, the approximation is going to not be quite as good. But because it's so close to that f of 2, then we can rest assured that the approximation, unless there's something real crazy going on with the equation, should be pretty accurate. Number 2 says determine the particular solution. Now here we're just kind of getting straight to it. We're going to separate out the x's and the y's. We're going to integrate both sides, solve for c, and finally we're going to solve for y. And that's really our ultimate goal here, is to figure out what equation for y, what y function would have its slope as 6x squared plus 3 over y squared. So let's go ahead and separate out the x's and the y's. I can do the take advantage of the cross products property, which says that you could multiply, or if you have a proportion where you have two equal fractions, you can multiply the numerator of one by the denominator of the other and set those two products equal to each other. So we have y squared dy equals 6x squared plus 3 dx, and we want to integrate both sides. The integral of y squared with respect to y is going to be y cubed divided by 3, and it's going to have its own little c value here. And then on the right-hand side, we're going to increase that exponent by 1 and divide the coefficient by 3. 6 divided by 3 is going to be 2 plus 3x. And then it's going to have its own constant. So from here, I can combine my two constants, which gives me 1/3 y cubed equals 2x cubed plus 3x plus c. I'm going to multiply both sides by 3 to get y cubed equals 6x cubed plus 9x plus c. And you might be wondering, well, why not 3c? Why don't I multiply that by 3? And the truth is you actually do multiply it by 3, but 3 times any constant is just another constant. And at the end of the day, it doesn't really matter what that constant is at this point until we actually need to find what that constant is. So now we're going to take the cube root of both sides. I'm going to continue on up here, and we'll get our equation y equals the cube root of 6x cubed plus 9x plus c. So now I need to figure out what is that c. And I can do that by using this coordinate that was given here, 1, 5. Okay, I'm going to plug in 5 for y, and I'm going to plug in 1 for x. And we're going to use this equation to figure out what that c value is. So 1 cubed is 1 times 6. It's going to be 6. And then 9 times 1 is 9. So we have 6 plus 9, which is 15. So 15 plus c. Now we need to cube both sides. Now 5 cubed, that might not be on your list of memorized values, but it's really just 5 times 5 times 5. 5 times 5 is 25, and 25 times 5, just imagine you had 5 quarters, you got $1.25, right? So this should be 125. Next, we can subtract 15 from both sides, and so I'm going to get c is 110. So now that I know what my c value is, I can go ahead and write my equation and be done with this problem. The particular solution for this differential equation is going to be y equals the cube root of 6x cubed plus 9x plus 110. Number 3 gives us another differential equation, and we're going to be tasked with finding y. Basically, it's the same kind of question that we saw in number 2. It's just worded a little bit differently. They still give us a point on the curve of f. They give us the differential, and so we're going to take the same basic steps to come up with that equation. So just like with the last one, we're going to use the cross products property and try to separate out the x's and the y. So that's going to be y dy equals 2x cubed minus 3 dx. Then I want to go ahead and integrate both sides with respect to their respective variables, y and x. The integral of y using that anti-power rule is going to be y squared divided by 2. And of course, it's got its little plus c on there, which will combine with the other plus c on the right-hand side in a minute. Using the power rule over here, we're going to get x to the 4th. 2 divided by 4 is going to reduce to 1/2 minus 3x. And it has its own little c value there. So now I'm going to combine those c values. So I have 1/2 y squared equals 1/2 x to the 4th minus 3x plus c. Multiply both sides by 2. So I get x to the 4th minus 6x. And then 2 times a constant is really still a constant. You might feel uncomfortable writing the c's here. You really don't need these subscripts. I just like to write them just to make it clear that there are 2 different constants that I'm combining there. But you don't have to be that specific. Finally, I need to take the square root of both sides. And the square root of y squared is the absolute value of y. So in practice, what that means is that if I want to isolate that y, I'm going to have a plus or minus over here. Now, when we have a function, it can only have one output for any given input. And so since the output or the value that I know, f of 1 equals -5, tells me that that output, at least at one point, has got to be negative. But this function is either going to output all positives or all negatives, right? Because the square root of something, oh boy, let's put that back in there. The square root of something is always going to give you a positive value, right? This is always going to be positive. And then I have that plus or minus going on there. So in order for it to be possible for there to be an output that is negative, they've all got to be negative. So I'm going to actually erase that positive and just stick with the negative. And maybe a better way of just showing that, I'm going to scratch that out. Okay, so this little point right here tells me that we're going to sort of pick or choose the negative, okay, not the positive version of that equation. So we've got our y, at least in terms of c, and in terms of x. So we need to figure out what that c is, and we're going to use that point once again to figure out what that c value is. So if x is 1, y is negative 5. So I've got negative 5 equals negative square root of 1 to the 4th minus 6 times 1 plus c. Now, both of these sides of the equation have a negative, so I can either multiply or divide both sides by negative 1 and effectively get rid of those negatives. So I have 5 equals the square root. We've got 1 minus 6. It's going to be negative 5 plus c. And now I could square both sides to get rid of that square root. 25 equals negative 5 plus c. So if I add 5 to both sides, I get 30 as my value for c. Now, since I know my value for c now, I can write my equation. What I've been looking for is this y equals negative the square root of x to the 4th minus 6x plus 30. Number 4, another very similar question. All the problems on the homework here should be relatively similar in terms of how you work them. The algebra might be a little different depending on how you end up setting up your equation, but the overall strategy should be the same. So just like the previous problems, we want to separate our y's and our x's. This is why they're called separable differential equations. Just a quick note here that not all differential equations are separable. So these are kind of set up in a way so that you're only getting separable differential equations. Now, how you solve for y given a non-separable or an unseparable differential equation, that's going to be a discussion for another day, not today. Anyway, once we try to separate the x and the y's here, again, we're going to use that cross product property and rewrite this as e to the y dy equals 3x squared dx. I do want to integrate both sides, and the integral of e to the y is just e to the y. So we get e to the y plus its constant, and then we've got x cubed, and then 3 divided by 3 is just 1. So we just get x cubed plus its constant. Combining the constants together gives me e to the y equals x cubed plus c. And still a lot of students I've seen have struggled with trying to isolate a variable when it's in the exponent. This is what logarithms are for. Don't forget that logarithms are inverses of exponential functions. So anytime you're trying to isolate an x and it's stuck inside of an exponent, you're likely going to have to take a logarithm of both sides to get it out. And also, if you've got an x that's stuck inside of a logarithm, you're going to use exponentiation to isolate that variable. They go back and forth because they are inverses, they undo each other, and that's how we use inverses to solve equations. So to get that y by itself, I need to take the natural log of both sides. So I'll have the natural log of e to the y equals the natural log of x cubed plus c. Now, the natural log of e to the y is just y, and that's kind of the whole point, why we took the natural log of both sides to begin with. So we get y equals the natural log of x cubed plus c, which would be good if we were looking for the general solution, but we want the particular solution such that 2, 0 is a point on that curve. So we need to figure out what c is. Okay, so to figure out c here, we're going to use 2, 0, where y is 0 and x is 2. And we're going to solve for c. So to get rid of that natural log, we have to invert it. If we just want like what's inside the parentheses there, which would be 8 plus c. So we need to take e to take e as a base and raise both of these sides as exponents of e. Now, e to the 0 is going to be 1. E to the natural log, that effectively cancels each other out, and we just get 8 plus c, which is why we rose both of those as exponents to e in the first place. And if we subtract 8 from both sides, we get negative 7 for c. So now we're ready to write our equation. Y equals the natural log of x cubed minus 7. Number 5 says consider the differential equation dy dx equals negative 2x over y. And part A says let y equals f of x be the particular solution. Again, another particular solution. I think every single question we've answered so far as separable differential equations are concerned have all been particular solutions. You should be prepared to find that particular solution and not just the general solution. with the initial condition that f of 1 equals -1. That's that coordinate that we're going to need. Part A wants us to write an equation for the line tangent to the graph at 1, -1, and use it to approximate f of 1.1. So this is going to be solved similar to how we did number 1, although part A and part B are basically combined into a part A here. So the point that we're going to use is 1, -1. We do need to find the slope at that point, but we can use this differential equation to find that slope. Remember, dy dx, that is just the slope of y, or in this case, f of x, since y is f of x. So either way, x is 1, y is -1, so the slope there would be -2 times, 1 over -1, so that'd be -2 over -1 is just +2, so the slope at that point is 2. Now I'm ready to write that equation, y minus -1, so y plus 1, equals the slope 2 times x minus 1. And yeah, there's your linear approximation. That's kind of the first part of this, is find an equation for the line tangent to the graph, and we got that. And now we're going to use it to approximate f of 1.1. So we're going to substitute in 1.1 into x. Y plus 1 equals 2 times 1.1 minus 1. 1.1 minus 1 is just going to be 0.1, 0.1, and then times 2 would be 0.2. Then if I subtract 1 from both sides, I'm going to get my approximation. 0.2 minus 1 would be the opposite of 1 minus 0.2, which is 0.8. So this is going to be negative 0.8. That's going to be my approximation. So f of 1.1 is approximately negative 0.8. Part B says find the particular solution to the given differential equation with that initial condition. So basically, we're going to do what we did in most of the other problems, which is to separate the y's from the x's, integrate both sides, and then once we've integrated both sides, we can solve for y and then solve for c. So let's go ahead and separate the y's and the x's. If I multiply both sides by y and both sides by dx, I'm going to get y dy equals negative 2x dx. And then integrating both sides is going to result in y squared divided by 2, so 1/2 y squared plus some constant equals, x squared, and then divide by 2. Negative 2 divided by 2 is -1, so negative x squared plus its own little constant. Combining the constants of both sides is going to give me 1/2 y squared equals negative x squared plus c. Now, if I want to isolate y, I'm going to first have to multiply both sides by 2. So I get y squared equals negative 2x squared plus c. And again, we've mentioned this several times at this point, but if you multiply a constant by a constant, you get a constant. So 2 times c is going to be some other constant. This c is definitely not the same value as this c, but it doesn't really matter with where we're going. The notation there, you can be a little sloppy there. You don't need to differentiate those two. So now I want to take the square root of both sides, but I want to be careful here. When I take the square root of both sides, like we've done before, we do get a plus or minus situation going here with the square root because the square root of y squared is absolute value of y. So we're taking a little shortcut here, just jumping straight to the plus minus square root. But we can use the coordinate that was given, f of 1 is -1, to determine that that output needs to be negative. So we are only going to take the negative version of this relation here. Let's scratch out that positive. Right here, y must be negative. Y is negative. So that's what we're going to use to find our c value. So let's find the c. Okay, we know the point 1 comma -1 is on that curve. So -1 can equal negative square root of -2 times 1 squared plus c. We could drop both negative signs on either side because we can multiply both sides by -1. So 1 is equal to the square root of 1 squared is 1 times -2 would be -2 plus c. Squaring both sides is not going to do anything to that left side because 1 squared is 1, but it'll get rid of the square root on the right-hand side. Then finally, we want to add 2 to both sides to get c equals 3. So we got our constant here, and we're ready to write our final answer, which we're basically going to copy this equation over here, but replace the c with a 3. So our final answer is y equals negative square root of negative 2x squared plus 3. All right, we only have a couple questions left here, number 6 and number 7. Let's start with number 6. Determine the solution. Okay, so we got another one of these. At this point, hopefully you know or at least have a pretty good idea of the steps that we're going to take to solve this. It's just going to be a matter of making sure that our algebra is good, and making sure we anti-differentiate correctly. So we do want to get our y's on both sides. You got to be a little more careful here because we can't just use the cross products property like we have in all the other ones. To get that root y over the other side, we're actually going to have to divide both sides by root y. So we're going to have 1 divided by root y dy equals 3x squared plus 4. And then if we multiply both sides by dx, we're going to get the dx over there. Now we're going to integrate both sides with respect to their variables. Now this 1 over square root of y can be interpreted as y to the negative 1/2. So using that anti-power rule, the power initially was negative 1/2, but adding 1 to that is going to bring it up to 1/2. And then dividing by half is the same thing as multiplying by 2. So we get 2y to the 1/2 plus a constant equals, using that power rule, x cubed. 3 divided by 3 is 1. Okay, plus 4x plus its constant. So 2y to the 1/2. And I'm going to move that constant over and at this point combine them. X cubed plus 4x plus c. And I want to divide both sides by 2 to get y to the 1/2 equals, let's see here, x cubed divided by 2. So 1/2 x cubed plus 2x, and then plus c. Just like when we multiplied a constant by a constant, we get a constant. Same thing goes for division as well. So right now I've got the square root of y equals all that. So I'm going to square both sides, but I want to be careful about that. This little step here, anytime you square both sides of an equation, you do run the risk of generating an extraneous solution because you're introducing a factor that is not there to begin with. And so what that means, unfortunately, is that we're going to have to check whatever answer we end up getting with this square root function. Okay. But that's okay. We do want to try to isolate y, so that's what we got to do. So if we square both sides, we're going to get y equals 1/2 x cubed plus 2x plus c quantity squared. Now, if we're going to solve for that c, which is what we need next, we're going to use the point 3, 9. We're going to plug in 3 into x and plug in 9 into y. So we have, let's see here, 9 equals 1/2 times 3 cubed plus 2 times 3 plus c squared. Okay, I'm going to take the square root of both sides. That's going to give me 3. Well, actually, square root of both sides could be plus or minus 3. So we want to be careful. It could be plus or minus 3 equals, let's see here, 3 cubed. That would be 27. Ugh, this is going to be kind of gross. 27 divided by 2 plus 6 plus c. I really don't like that, but here we go. 27 plus, okay, so 6 is 12 over 2. 12 and 27 is going to be 39 divided by 2 plus c. I think what might make this a little easier if we just, let's just go with it. So we're going to subtract 39 over 2 from both sides. 39 over 2 is negative, and then we're going to say plus or minus 3. Now, I'm going to rewrite 3 so that it has a common denominator and makes this to hopefully make this addition subtraction a little bit easier. So, yeah, 3 is the same thing as 6 over 2. And these two values could potentially be c. We do need to check them with this equation over here, making sure that, they both work. Most likely only one of them is going to work. So let's see here. Negative 39 plus 6 would be negative 33 over 2. Or we might get negative 39 over 2 plus 6, or sorry, minus 6 over 2, and that's going to be 45 over 2. So one of these is going to be right and one of them isn't. We do need to check here. So let's just check, see which one actually works. So I'm going to use, again, I'm going to go back to this equation I had before I squared both sides. Recall that squaring both sides, that's really what is going to generate this extraneous solution here. So we're going to go back to before we did that and see which one of these is actually going to work out. So we've got the square root of y. So the square root of, so here we're going to check. Just make a little note that we're checking each one of these c values. So for the left-hand one, we've got the square root of y, which is 9, equals 1/2 times negative 33 over 2 cubed. Oh, I'm going to have to do that by hand. That is not going to be very nice, but let's see. Minus 33 halves. Okay, so square root of 9 is 3. Wait a minute. Oh, no, I don't want 33 over 2 over there. What am I doing? This isn't going to be as bad as I thought. Yeah, because it's 1/2 times x cubed, not times c cubed. So the x here is 3. So not as bad as I thought at first. So that's 27 divided by 2 plus 6. Now 6 is the same thing as 12 over 2. So I might as well just keep those over 2's to make this a little easier. And we have minus 33 over 2. So let's see what we have here. We got 27 plus 12, that's 39. 39 minus 33. Okay, 39 minus 33, that is 6. 6 divided by 2 is 3. So that checks out. That means this is going to be our C value. You could check the 45 over 2. I'm kind of running out of space here, but hopefully you can see why it wouldn't work. You'd use this exact same equation, but instead of minus 33 over 2, you'd have plus 45 over 2. And so if the only thing we're changing is this guy right here, we'd have 27 plus 12 would be 39, but adding an extra 45 over 2, it's just going to be too big of a number for that to equal 3. So we do get an extraneous solution here with this 45 over 2. So we can go ahead and write our answer here, and I am running out of room, so I'm going to do my best to just kind of squeeze this in. Y equals 1/2 x cubed plus 2x minus 33 over 2 quantity squared. Whew. That's kind of a tough one. Yeah, anytime you got to square both sides, that usually is going to cause some issues. Okay, number 7, last problem with the homework. Which of the following is a solution to the differential equation with the initial condition? This is the same type of problem that we've worked before, but it is multiple choice. And as we've seen with a lot of multiple choice questions, sometimes the challenge is not actually solving the problem. You might know how to solve this problem. We've done enough of them, so hopefully you kind of have an idea of where this is going to go. But you do have to make sure that your answer matches one of the answer choices. So sometimes that takes a little bit of algebraic manipulation to force your correct answer to look like the given answer choices. Not always, but just kind of go into a multiple choice question being aware that that may occur. So let's isolate or separate rather the y's from the x's. So we're going to have y dy equals x squared dx, just using that cross product property like we have in the past. I'm going to integrate both sides, and the integral of y is going to be 1/2 y squared plus c. And I'm actually not even going to bother. We've done enough of these. We know that we're going to move that c to the other side anyway. So I'm just going to kind of skip that for now. The integral here is going to be 1/3 x cubed, and then we have that plus c. So just kind of assume that we combine them afterwards. We knew that was going to happen anyway. Then we're going to multiply everything by 2. So y squared is going to be 2/3 x cubed, and then 2 times c is just some other constant. Finally, we're going to take the square root of both sides, and that is going to give me absolute value of y equals 2/3. Sorry, not equals 2/3, but equals the square root and I'm kind of squeezing this in here, so maybe I'll rewrite it over here. We got the absolute value of y equals the square root of 2/3 x cubed plus c. To get rid of that absolute value, all you have to do is just move or place a plus or minus on the other side. Now, since we know that y of 3 equals -2, we know that output for y has to be negative, and we've seen a couple of these so far. And anytime you have plus or minus square root, if you need one of the outputs to be negative, then they all kind of have to be negative. It's not like you get to pick and choose. It's either all going to be positive or all going to be negative. So we're going to ignore that plus and just go with the negative. The last thing to do here is to figure out what the c value is. So we can use the coordinate 3, -2, plug that into x, plug it into y to get that c. The y value is -2, so -2 equals negative square root of 2/3 times 3 cubed plus c. I'm going to drop those negative signs. I can do that by multiplying or dividing both sides by -1. Then I have the square root of, let's see here, we got 2 divided by 3 times 3 cubed. Well, if I'm going to divide by 3 and then multiply by 3 3's, that's really the same thing as multiplying by 2 3's, because one of those 3's will just reduce to 1. So, yeah, we got 27 divided by 3. That's going to be 9 times 2 is 18 plus c. Now, if I square both sides, I'm going to get 4 equals 18 plus c. Subtracting both sides by 18 is going to give me -14 as my c value. So now that I have my c value, I can go ahead and write my equation. Y, and again, we might have to kind of mess with it a little bit, but it shouldn't be too big of a deal. We've got y equals negative the square root of 2/3 x cubed minus 14. And we kind of lucked out, not really any significant manipulation required to see that the answer is D. Really the only thing is rewriting that term as 2x cubed over 3. But luckily we did not have to do anything more complicated than that. So that's going to wrap it up for tonight's homework. Keep practicing with these, or we will keep practicing with these differential equations in the next couple days. So if you're still kind of struggling with the algebra and making sure you get the right answer, just know that we will continue to work on this for the next week or so. You'll have a great day, and I'll see you next time.